What's up, everybody? I'm the Nature Hacker, and this is your world. Don't you forget that. So, we were talking about MAVI, muon oxygen vacancy implosion fusion. MAVI fusion. And we basically said that all we need is some oxide. I mean, I could say anything that can have vacancies. You know, maybe it could be a fluoride or a chloride or an iodide or something. But let's just say, for simplification purposes, an oxide. So we have an oxide, and now all we need to do in order to create MAVI fusion is to fill oxygen vacancies with muons. So I'm just going to tie up some of the loose ends in the process and the idea here, and that is basically what we were saying before is that we need neutrons in order to create gold. For example, in order to create gold, we need neutrons to convert iron 54 and 56, the most common isotopes of iron. We need to convert those into iron 55 so that it can create gold. And one of those things is, what we need to do that is neutron radiation. So we need to hit that iron with neutron radiation to make iron 55. How do we do that? Well, muons can do that for us. Muons, a muon plus a proton equals a neutron. So basically, I'm pretty convinced that all a neutron is a hydrogen atom that has a muon instead of an electron. Muons can attach to nuclei even with electrons present. So muons are kind of like ghost electrons. They can go into the interior of a nucleus. They're not bound out to outer orbital like an electron is, so they can go into the nucleus even when other electrons are present. But what I believe is a neutron is a proton, just a hydrogen atom that has no electrons, so an H+, right, that has a muon in it. So a neutron is just a hydrogen ion with a muon, is what I believe. And that is, just from the equation, which is true, proton plus muon equals neutron, then that's pretty obvious to believe what I believe about what a neutron is. Anyway, what we know is that we can create neutrons from protons with muons. Muons can go into a nucleus and convert a proton into a neutron. That's where our neutron radiation comes from. When you convert a proton to a neutron in the nucleus, that neutron becomes free, and it can shoot off and create neutron radiation, because neutrons are not bound into the nucleus like protons are. They're not segregated into the middle, because you got all these electrons around, and those hold all the positively charged protons in the middle. But when you convert one of those protons to a neutron, it can be free to leave the atom, creating neutron radiation, and when that hits iron, it can and will convert the iron into iron 55. So we just need muons. Muons can do everything for us. They can make us the iron 55. They can make the structural implosion. They can catalyze a structural implosion. There might need to be extra energy. The muons at least are just catalysts. Maybe the muons are what caused the collapse of the structure. Maybe they're just catalysts reducing the energy required. The energy that we're going to be using is charge, is voltage. So that's the energy we're going to be using. So but the cool thing here is that I found out how to make muons. I found what we need is negative muons. And I found out how to do that. I found a paper, and that should be in the link below, of how negative muons are created. And the way they're created is you have an electron beam, which is like a cathode ray. It's basically, like a fluorescent lamp. That's basically it. You have the electrons flowing through, causing the fluorescence of the gas in there. So that's basically what it is. Electron beam hits. You have an electron beam go through copper, hit copper, and that produces a muon beam. Because basically what a muon is it's an electrified neutrino, basically, like a teensy weensy weensy particle that has an electron bound into it or whatnot. So it's that. So it's like a little grainy electron. It's got a little bit of nucleus in it, just a teensy bit of nucleus in it. So anyway, you hit the electrons against something like copper, and it strips away some junk from that copper and creating muons out of the electrons. So that's how we create negative muons. That sounds a lot like, a spark. Let's say we have, our gold experiment, which is iron oxide, iron 3 oxide hematite, with, some electrodes with a high voltage differential between the electrodes using our high voltage power supply, roughly 3 million volts is what I'm shooting for. So you have an electrical discharge going through that iron oxide. You're going to get muons created. I mean, muons are created whenever electrons hit matter. That's the most basic thing going on. Electrons slam through matter and kick off muons. Okay, so you're zapping your iron oxide with electrons, with electricity, right? Like little sparks going through. We're gonna have a pulsing power supply, so we'll have sparks going through. So anyway, those sparks will create muons, and the muons will create neutrons, which convert the iron to iron 55. They also will fill the oxygen vacancies, which is also caused by the electrical charge here. Will create oxygen vacancies. The muons will fill the oxygen vacancies. So we're creating muons in this process. We're creating neutrons in this process. We're creating oxygen. Did I say that already? We're creating oxygen vacancies. We're creating neutrons. We're creating muons. And we're filling the oxygen vacancies with muons, all through just this process of electrical discharge. All of those things can and will be created just from electrical discharge, and you do need a lot of high voltage to do it. So I'd say that's pretty much it. But yeah, so we're creating the muons. And what else did I want to say about the muons? Muons. Like I said, link in the description below about the laboratory creating muons. This has been going on for 50 years. They've been doing this, creating muons. So yeah, just an electrical discharge onto matter like copper. It's going to heat up a lot. I mean, ideally you're going to want probably liquid nitrogen cooling. Which is interesting. Yeah, so anyway, liquid nitrogen cooling. Ideally, you just want this to be really cold so that you got a nice stream of muons coming off. Oh, but what I did want to say is that once you start creating gold, right? Remember how we said there's like this effect of nuclear melting where you see this melted spot of gold on the hematite or into the hematite, right? And we were talking before about how muons can be recycled. So one muon can convert a section into gold, can go over here, convert that section into gold. So you're going to have a melt-looking thing just from that chain reaction of muons. But what also is interesting in this paper that I referenced in the link below, they say that gold is pretty much the best thing to hit with electrons to create muons. So now, boom, wow, we have another chain reaction, and that is once we start creating some gold, then the electrons hitting that gold will release even more muons than when it was just hitting the iron, the iron oxide. So that will create an exponentializing chain reaction where the more gold you create, the more muons will be created. Therefore, the more gold you create. It's kind of this positive feedback loop. You create some gold, then you create more muons, which create more gold, which create more muons, which create more gold. So you have this chain reaction. It's called a positive feedback loop in certain fields of science. That's how we do it. We take I mean, this is just an example. You can take any oxide, probably any chloride or even a hydride or fluoride, but let's just say oxide for now. But this includes anything that can have vacancies, okay? And right now we're talking about a negative muon. We might be able to have a positive vacancy and use positive muons to do something else. I don't know. But that should also be included in this. So anything with vacancies and with muons is in this process, in this process that I'm describing here. So a process is something that can be patented, and so basically what I'm doing is releasing the open source patent, so anyone can do it, anyone can profit off of it, whatever you want to do with the information. So all we need is an oxide, something that can have vacancies. We need a muon source. In this case, we're using electricity. And we're killing multiple birds with one stone with this electricity. We're creating muons. We're using some of those muons to create neutrons, to create iron-55. We're also using some of the muons. We're using the electricity to create oxygen vacancies in our oxide. And we're filling those vacancies with muons, creating a MAVI fusion. MAVI, again, standing for muon oxygen vacancy implosion and then fusion. So we're doing multiple things with this electricity, but really all we need is a very high voltage with an oxide in between it. That's it. Very high voltage oxide. This is one way to do it, okay? There's other ways to do it, like how it's done in the Earth. It uses a reducing agent of hydrogen telluride or hydrogen sulfide and quartz to carry the charge. But basically, what it still comes down to is hematite charge, potential difference, voltage, hematite, as far as making gold. So that's all we have. That's really what it breaks down to. In the Earth, we have the hydrogen sulfide rushing by the quartz, charging the quartz up. Positive or negative on this side, positive on this side, hematite in here, and then negative on this side, so really we're just doing the same thing. We have our positive and negative. This time we don't need the hydrogen telluride, we don't need the quartz. Those are all just for it to be done chemically, but we're just going to do it straight electrically with a high voltage power supply with an oxide in there, in our case hematite, because we want to make gold first. Eventually I want to make iridium and platinum and stuff too. I believe platinum, you can use manganese oxide instead of iron oxides to make platinum. But right now gold is the most expensive noble metal. Even though iridium is much more noble than gold is, still gold is the most expensive. So we'll make gold, the price will probably come down, and when it comes down we'll switch to other metals to make those, which will be good for everyone. We'll get plenty of all types of precious metals for everyone, and we'll be able to do a lot. Precious metals, they don't seem like they're that valuable, that useful, other than corrosion resistance and stuff, but my noble metal battery, if you want to Google noble metal battery, which I also invented, needs noble metals. Iridium is the best. It's going to need gold. In any case, my noble metal battery will need gold, because in order to electroplate iridium, you need to have a gold layer just the way it is. So in order to make our iridium electrodes, which is iridium is the best cathode in a battery possible, we're going to need gold to electroplate iridium onto something, so we don't have to use pure iridium, which would be too expensive. Anyway, noble metals are useful, so we're going to make gold, and the way we do that is MAVI fusion. The way that's done is by, in its simplest form, a potential difference across an oxide layer. So we're going to get zaps going through that oxide. Those zaps are going to be creating muons, they're going to be creating neutrons, they're going to be creating iron-55, they're going to be creating oxygen vacancies, they're going to be filling the oxygen vacancies with the muons, and maybe that's all that's needed for that collapse. Maybe extra potential plus the muons and the vacancies will cause it, but that is the basics. So, ladies and gentlemen, it's over. The theoretical process, the theorizing is all completed. we now have the completed process. Everything's verified in the science. Like I said, link down in the description. Anything else you want to know, Google it. Learn how to become a good Googler or a good researcher. Even in real science, we Google to find references, to find papers and stuff. So you're doing real research. They say that, you know, a day in the library is worth a month in the lab. So be smart. Work smart, not hard. Don't go out doing tons of experiments before you've really grasped all the research and know where you stand. So we have our theoretical framework for our theory on how gold is made in the earth. We also have a process, a profitable process, hopefully, to create noble metals and whatever we want from oxides using electricity. Pretty simple. High voltage is needed. Be very careful. You need direct current, DC, to create the oxygen vacancies. To create the muons, we need DC, just the way it is. Maybe you can create muons with AC, like a Tesla coil, but probably not. I mean, you definitely can't create the oxygen vacancies with AC. So we're going to need DC. DC pulses is probably the best. I have a post on naturehackerproducts.com, and I linked to that post in I think my last video. So that post tells you a process to make a multi-million volt power supply. Just be very careful. DC, high voltage DC, is extremely dangerous. You could kill yourself with one of these power supplies. Don't zap yourself. I mean, I don't know how to, you know, just be really safe, you know. It's crazy. These high volt, like millions of volts, the spark can jump many feet, so you don't want to be grounded when you're dealing with this. I don't know, just be very careful. It's going to be very dangerous. Anyway, thanks for watching. Let me see if there's any comments really quick. Why am I shirtless? Good to see you, Brooke. Because you're the millionth person to ask that. But because I didn't have a shirt on, that's why I'm shirtless. Because I'm real, I'm raw, and I don't care what anybody thinks. So, anyway, thanks for watching. Until next time, I am the Nature Hacker. Let's do work.